Hi, and welcome to our talk about how design choices can affect perceived accountability of smart appliances. This project is part of the University of British Columbia's Designing for People practicum, a team-oriented design project in which students collaborate with external partners. As automated systems grow in popularity, questions arise about who is held accountable for their actions. Here, we define accountability as the combination of taking responsibility for carrying out an action and ownership for the outcome. The literature suggests that accountability assignment depends on social context, including risk, uncertainty, and trust amongst the involved parties. We wanted to investigate whether design factors could impact user perception of the accountability of automated systems, and if so, which design choices were relevant. Our industry partner was considering adding voice user interfaces, VUIs, to their home appliances. We thought this was a great opportunity to study accountability delegation for automated systems because the conversational interaction style of VUIs creates opportunities for system automation. We needed a device with a complex interface and many settings because it was important that the automated system was held accountable for its choices rather than just its success at carrying out a single function. From a wide range of smart home appliances, we focused on washing machines because setting one requires many choices such as water temperature, fabric type, etc. However, since automated VUI washing machines were not commercially available at the time of the study, we used walkthrough-style video prototypes to assess user perceptions of the interactions. To better understand perspectives on VUI appliances in the home, we ran an exploratory experiment with 43 participants in an online questionnaire and 10 interviewees. This revealed 3 situational factors affecting accountability of automated systems. Those included the complexity of the tasks, the ambiguity of the commands used, and the type of user, specifically whether they were primary or secondary deployers of technology in the home. For more detail on our exploratory study, please see our paper. We unpacked accountability using Booz et al.'s theoretical framework of control capabilities. Specifically, we used Booz's control capabilities of predictability and transparency. Our exploratory study also indicated the reliability of a system was a key component of its accountability. In our main study, we measured these 3 control capabilities in addition to directly ask participants about system accountability. We asked participants to watch 8 different walkthrough videos of 4 different laundry machines in a randomized order. One was fully automated. The user describes their laundry, for example, by saying, "medium load of delicates," and the washing machine autonomously chooses and executes the correct wash. Like full automation, the recommendation-based machine listens to descriptions of the laundry, but then proposes 2 suggestions of wash cycles for the user to choose between. The instruction-based system guides users to describing their clothes and then provides justified suggestions of wash cycles. For example, the machine justifies an extra rinse by explaining that wool is more likely to hold detergent residue. Finally, the command-based system is much like a standard washing machine, except the user states their choices instead of pressing buttons. For each machine, users were shown 2 videos in which the washer failed to remove stains, but one was a low-complexity task and the other was high complexity. Users were asked to rank the system in terms of accountability. Users also scored each system on a 0 to 100-point scale for transparency, predictability, reliability, and their projected satisfaction had they been the ones interacting with the machines. For both low and high complexity tasks, users ranked the automation system as the most accountable and the command system as the least accountable, which aligned with our hypothesis that automation is linked to accountability. For control capabilities of transparency, predictability, and reliability, we found significant differences between mechanisms only for predictability in the high-complexity task, but the trends in our data suggest that increased automation is linked to reduced transparency and predictability. I'll leave you with the takeaways and design implications of this project. First of all, the most important and clear takeaway from our study is that designers can control the perceived accountability by manipulating dialogue design, particularly whether the system offers and justifies choices to the user. This can impact users' perception of accountability. Our work suggests that designing predictable, reliable, and transparent systems can reduce perceived system accountability. User satisfaction increased along with automation, but so did system accountability. This effectively creates a trade-off for designers who must then consider the unique context of the product in question. One way around this trade-off is a system with transitional mechanisms, so one that starts by offering justification for all its recommendations, but gradually becomes more automated. Please refer to our paper for an extended discussion of our methods and findings, and thank you for listening.